First of all, I welcome you all. And yeah, of course, I would like to acknowledge the timing of this and the current era where we are living. So I wish you all are with your families and you are staying safe and healthy. Next about me, I am Ajit Kumar Pandey. I am alumni of IcfaiTech. So I am from one of the first batch, 2004 to 2008. I live in Germany with my family, and I work here as a senior design engineer in analog and mixed signal design domain. So what we do is that we design optical transceivers for long haul and short haul data center interconnect type of connections. So this is mainly in the optical communication. So I'm an engineer who is combining electronics engineering with optical communications to make this technology even faster, even better. So today I have been given this opportunity to talk on new age engineering career with all of you. As I have been told, the audience today is mostly the new students who are aspiring to become an engineer, or maybe some of existing students who are in their first or second year of engineering. Do we have anyone else on this call today?
Yeah, we have few faculty, Ajit, but you can proceed.
No,
Yeah.
other than faculties, from the audience's point of view, do we have anyone else like fourth year student or somebody else?
Maybe few of them might be present there in this.
Mm-hmm.
Yeah.
Okay. So this is how today's agenda look like, and I'm going to make this fancy term new age engineering a little bit clear, that what it means, or at least I'll try to make it clear for all of you that what this fancy term is. And then we will see that what it really means for a student, somebody who is becoming an engineering student now, or let's say is in the beginning of engineering studies. So what does this new age engineering means? And then let's say if someone is looking to become an engineer, just trying to find a career in engineering, trying to find a university, then how should that person choose the field of engineering from this new engineering point of view? And how does the career path then looks like once you have completed your engineering? This is a very short agenda. In the end, we will have some time for your questions, suggestions, and discussion. So I would really appreciate if you guys share your thoughts as well. And at any point, feel free to stop me and ask any questions or anything which is not clear. You are more than welcome. My only sincere request to all of you would be, who is not speaking, please mute your mic. It will really help others and it will make me audible. And I thank you a lot for this understanding. So let's start with this little video here. Yeah, so I will play a video here. If there's a bandwidth problem, if it's not playing, don't worry. I will also explain in words that what I'm showing. So I will start this video. So by the way, it says that it's a park house. It says in German, but I will just translate. It says that park house pilot, please get out of the car and start Audi Park House Pilot app. This is what it says here. So, was the video visible?
Yes, yes.
Yes.
Okay, so what we just saw is that a guy drives in with his Audi in a parking house, and at the entrance of the parking house, he gets down from the car and just uses an app and says that park my car. And this app then connects to the car, and then car is driving fully autonomously without any driver present in the car. It goes to its designated parking place and it parks itself. And then when the guy needs his car, he's standing at the entrance, and in the app, he says, bring my car back. And his car is back to him. And this is without any interference from any active driver. There was no driver in the car, and the car was able to do it on its own. And this is why autonomous parking. But as easy as it seems, it really isn't. Just think about it. The guy is standing at the entrance. He has no idea that how many cars are there in the parking house already. Is there someone standing, maybe a small child who is on the way of the car? And still he believes his car, and he allows it to do it on its own. What happens if there's a small accident there? But the thing is, the guy is very confident the car can do this. A car can do this maneuver automatically and autonomously, and he believes it. But in order for a car owner who is doing this, in order for him to believe that a car is able to do this autonomously, it's a really huge thing. And if engineering is making it happen, it's a really crazy time we are living in, where a car could park itself without help from anyone, without making an accident, and making sure that if there's a possibility of an accident happening, the car will detect that and prevent that accident. If it's your car and if it's in a parking house and if it hits a child, think the mess you will be in. But still you are depending on this technology, and you're saying that let it happen. And the car is able to do it. This is an excellent feat of engineering, on what I think. And can anyone guess how old this video is? Any wild guesses how old this could be?
3-4 years.
Wow, this idea has gone in research and all at least 6 to 7 years, 8 years ago. And the day this video is posted on YouTube is at least 2.5 years old. This was shown by one of the video uploaders that Audi has already achieved this, and this is already in function. So the thing here is that in 2018, the car was already able to do this. So the question now is that what is it already doing now in 2020, and what is the future ahead? So it says that how the engineers of today are thinking and what they are planning in future. Some 10 to 15 years ago, a high-level researcher in an automobile company could have only imagined that probably someday this would do, but for a normal person, this wasn't possible to imagine. This was unthinkable that a car would be doing this on its own. And to get this safely done, oh, by the way, when this functionality is being implemented, the car maker is making sure that no accident is happening. But how are they making it sure that no accident is happening? By employing rigorous testing. Do you know that how many faults in a million testing of a car is allowed in such functions, which are safety critical, which could be which could cause human life damage? If 1 million of such tests are happening, absolutely zero errors are allowed. It means that if you are testing 1 million autonomous parkings, if single error happens, that system will be scrapped. No one will be using that system. So the possibility of error is absolutely nothing. You can't make an error when you're designing the system as an engineer. When you design an autonomous parking system as an engineer, you are not allowed to make a mistake, because one small error and a life could be at risk. And that is how tight the engineering criteria today are, and they are where they are moving. So what do you think that how is this car able to do that? Look at this. Just for an autonomous parking feature in a car, how many engineering fields are involved? Mechanical, automotive, electrical, electronics, communications, data sciences, embedded systems, sensors, software engineering. And these are those fields which were top of my mind. And when I started putting this together, I just thought, okay, let's see, how many sensors are there in a car today? So I just did a quick Google search, and I tried to see that a car like Tesla or Mercedes and Audi, how many sensors are they putting there, and what's their plan? And what I read is really, really crazy. Just from sensors point of view, today a car could have up to 200 sensors. Up to 200 sensors. Look at some of the sensors here, which I've got. And this is with respect to 200 sensors, this is a really small list. Look how many sensors are there. And an amazing thing, why this number 200 sensors, or even the number of sensors what we see on the screen, why is this this really amazing? Why do I react when I see that these many sensors are there in a car? The thing is, you can put as many sensors you want, but unless and until they are interacting with each other in real time and able to provide a real-time feedback to the car, putting all these sensors in a car is making no sense. And here, at least two things are important. First, a ton of sensors, so many sensors, and a real-time information. So what really is real-time information? Do you think, do you say 1 second lag between something happening and then its reaction? So a reaction time of 1 second, do you think is real time? Or do you think 10 seconds is real time? Or do you think 0.001 seconds is real time? So what does really real time mean here? Real time means that as soon as a car sensor detects a small child in a parking house, it brakes as soon as possible, 0.001 seconds or even less, as soon as possible. And this is what you will say real time, because the criteria here is a human life. And to save a human life, if you delay braking of a car by 1 second or 2 seconds, the accident might already have happened. So are we really saying that 1 second lag is real time, and is it allowed? I don't think so in this case. So a sensor has to work in real time, feed its data, bring everything together, and make the decision. All of these things should happen in real time. This is one sensor. So a single sensor in a car is working in real time where the lag is less than 1 second. Now think that there are 200 sensors in the car, and they are all working at the same speed together, and they have all of this data has to come together, processed, and then a decision has to be made whether the car has to go forward or it has to stop. So just imagine the size of that data which is being processed, the time in which this is being processed, and then the car is making the decision. This is amazing. 200 sensors with a lag of less than 1 second, less than half seconds, all working together continuously, feeding data to the car and making it do something on its own. Just think how huge this thing is. Tons of engineering is involved in this. And when a car, in this case, when a car has detected a child on its way, it has to brake. Braking function there is the only one which when somebody says, what is the functionality of a car? You will say braking. Yeah, braking is one of the functionality of the car. And this is purely from mechanical and automotive perspective. Somebody could understand, okay, there's a brake. It applies to the wheels and the car stops. This is typical automotive engineering, or this is part of maybe typical mechanical engineering. But the thing is, this is not done by a human. This is done by a system. So really, tons of different engineering fields have to come together to make this happen. Unless and until all the engineering fields which I have mentioned together, they are coming together and working synchronously, it won't be possible. And when I say that all these engineerings have to come together, it really means that engineers, individual engineers from all these fields have to come to a single table and start sharing their knowledge and say that, okay, this is what I bring on the table, this is what I bring on the table, and then they make this happen. But then imagine that just for this autonomous parking, you have to bring engineers from all these fields. How feasible this is? And is it really cost effective for a company to do this? If they try to do it in this way and develop autonomous parking, just one functionality of the car, it is going to cost them millions of euros and millions of dollars. Then how are they making profit? Will this be a really feasible business? And these all things, these all thoughts have brought the engineering, the previous engineering towards a new age engineering. So when we say a new age engineering, in this new age is a really crazy term. Engineering, we all understand what it is. Yeah. So from ages we are hearing that what comes in an engineering. If you say engineering, mechanical engineer is an engineering. Mechanical engineer is part of an engineering. But then you add this fancy term, new age. A new age engineering. So what does it really mean? If there's a new age engineering, it means there was a previous age engineering. That automatically implies. And previous age engineering, I know that mechanical engineering or electrical and electronics engineering was so-called earlier engineering. But if this is not, if this is different than what we have today is in engineering, then we say that it's a new age. And if it's same, then why are we calling it new age? So what I feel from my point of my personal point of view, that the high diversity and interdisciplinary nature of the engineers who are involved in a technology today are making engineering the new age engineering. What we just saw in autonomous parking's case, that for this to happen on a single table, engineers from 10 different engineering fields have to come together. And that is what I mean by highly diverse and interdisciplinary nature. So this autonomous parking technology of a car is truly a highly diverse and interdisciplinary nature in engineering. And when something like this happens, I feel that this is what is new age engineering. Some of the examples of today's, some of the examples from today's, let's say, technical news. Yeah. So when you look into newspapers or when you read or listen news somewhere, and if you are focused on technical news, that what's happening in the technology and science field, these terms what you see here, 5G wireless, autonomous driving robots, artificial intelligence, big data, blockchain, Internet of Things, Industry 4.0, these have become really common. Of course, 5-6 years ago, we all had started hearing. A common person, when I say we all, I mean a common person has started hearing about 5G wireless network. Something is coming in 5G. This was a little bit relatable because we had already seen 2G, 3G, and 4G. And then somebody was saying that 5G is coming, so it was a little bit relatable. Okay, yeah, something new in this phone technology and wireless networking is going to come, and this is going to be fast and better and blah blah. This was a little bit relatable for a common man. But look at the other things: autonomous driving, robots, artificial intelligence, big data. These things have become really, really common now. And a child who is just out of, or I should not say child, a teenager who is just out of his school, who's planning for his career in engineering, as soon as he starts looking in this term today, he comes across all these fancy terms. And none of these fancy terms are actually clear indication of an engineering field. Can you say by looking at it, can you say what is the most important core engineering field in one of these fancy terms? If I once again take the example of autonomous driving, by that video you understood that, okay, this is the autonomous driving. But if I ask you what is the core engineering field which has utmost importance in this autonomous driving, what would be the answer? Is it automotive engineering? Is it electronics? Is it sensors, embedded systems? Which is most important in this autonomous driving? It's really difficult to say. So a new person who is trying to start his career, who has just started thinking about engineering and pursuing this as a career, and he does some research, talks to people, or in whichever way, whatever way, he comes across these things, which more or less a byproduct of today's new age engineering. And this term could be at times confusing, because it's not really clear that what really is happening in terms of field of study here. You are getting a 5G wireless network out, but it might not be clear that which engineering field or fields you have to get mastery in to be part of this 5G wireless networks rollout. So this is really important for somebody who is aspiring to become an engineer. It is really important that that person understands what really future holds in terms of engineering for us. So I will give you an example now that what new age engineering is in terms of field of study. What do you have to study to be called a new age engineer? So I have an example here, very famous, you see across all universities now, with core subjects which universities offer: mechanical, electrical, electronics, civil, chemical engineering. You mostly see a term mechatronics engineering. Again, a fancy term, but if you look into more detail, you will see that it's combination of, once again, three different core engineerings, mainly three different core engineerings: electrical, information technology, and mechanical engineering. Each of these are individual core engineering which has its own technology, which has its own study, its own knowledge base, and then its own and once you are done with your study, its own career path, and then so forth and so on. But then what you are, and I am an electrical and electronics engineer. It took 4 years for me to just complete this electrical and electronics engineers as bachelor's. So if I have to learn now 3, my bachelor's would be what, 12 years? And that does not sound feasible. That does not sound doable. But a car manufacturer, this is what he wants. He wants an engineer who knows, who has idea of all these 3 separate engineering fields. So how do we do it? The idea would be then to bring part of these core engineerings together and make it useful for, let's say, that car engineer, for that car engineering company. So you take electrical, information, and mechanical engineering, combine them together in such a way that Audi car manufacturer or Mercedes or whoever it is can have this engineer which he requires. So now, instead of having 10 different engineers from 10 different fields on a single table, you maybe need 3 or 4 who could do this. Is it cost effective? Yes. Does it make sense? Absolutely. And this is why new engineering fields are coming up in terms of your bachelor and master's degrees. And mechatronics is really one of them. So what happens when someone goes and says that I want to become an electrical engineer? He goes in depth of electrical engineering and learns tons of things. But in this learning, so what makes an electrical engineering study from 20 years, 30 years ago different than what we have today? Or in other words, what we have today, how is it different than the 30 years old core electrical engineering? So for any engineering, the basic thing is the technology, the underlying technology of that engineering. Yeah. For example, if you take software engineering, for a software engineering, a software language, a language program is a core ingredient. Yeah. So you with tons of other things, you really have to learn, let's say, programming for able to become a successful software engineer. So how has this software evolved? Every now and then you see a new software language coming up. C, C++, there was Java, there's Python, there's something else. And 5 years from down the line, there will be something absolutely new. So what has happened here in software engineering? Software engineering as a core engineering is as it is, but its underlying technology on which it is based on has changed. So now look at this from a bird's eye view. First, what you are doing is that you are bringing 3 different engineerings and you are bringing them together to create a new engineering field. This is absolutely new thing, top of the class thinking. But the core engineering, the basic underlying technology of this engineering is also getting upgraded. So your development is twofold here. You are upgrading the underlying technology of the core engineering, first point, and then you are bringing different core engineerings together to make a new engineering itself. And this is the reason why we see these technological advances in today's time, which is so fast. What 10 years ago took 10 years to develop, from today on, that might take only 5 or 6 years to develop. And these things are possible because of these new age engineering concepts, where you are bringing multiple engineering fields together, combining them, and you are also changing the underlying technology of the core engineering. And this is what you have to understand if you are planning your career in engineering today. Going forward, the new age engineerings will change the way we think about technology and the way we use it. And it is important to understand that how this is happening. And once you understand, then you can think, and then you can relate yourself to it and see where you stand from engineering career's point of view. So from that point, what really it means, this new age engineering, what really it means for today's students. I could not give a better example here than bringing my own transcripts from bachelor and master studies. What you see on the left hand side are those subjects which I have studied in bachelor's in IcfaiTech, year 2000 to 2004 to 2008. So roughly 12 years ago. The course list here on your left hand side of the screen. This is 12 years old btech program of electrical and electronics engineering. And what you see on right hand side is part of my master's transcript, which I studied in 2014 and 2016. Okay, in last 5 years, so I say relatively recent. And what you would notice that once you go down here, so further and further in your studies, 7th, 6th, 7th, 8th semesters, I always wanted to focus on electronics and devices. So my subjects here are all absolutely core related to electronics engineering. Yeah. So in engineering, what happens is that you, in the beginning of your courses, you learn all basics of engineering, of course, because it's based on those basics, and then you go towards more specialization. So in a typical electrical and electronics engineering course, 10 to 12 years ago was really this. And if you look more detail into it, you won't find many cross-disciplinary subjects. I wanted to do become an electronics engineer, and so I had an opportunity to select subjects from this field and then go on. Later, when I started my master's studies, I had an option that, okay, electronics engineers, but for what? Should I design cars? Should I design networks? Should I design mobiles? What do I do? And I decided that, okay, I have some experience in communications engineering. So when I was, after my bachelor's, when I was in India 6 years, I worked with TCS and Deloitte and Atos and what else? Yeah, so these companies, and when I was working there, I worked as IT and network engineer. So I had some idea of communications, that how this happens, how one device talks to another device in the world, and I was really interested in it, and I got an opportunity. I said, okay, let's do specialization in this. So what you will notice here, integrated circuits for wireless communication, fast integrated circuits for digital communications. This is what I wanted to do. But look at some of my other subject: advanced system theory, modeling and simulation, topics in systems in engineering, introduction to algorithms. At the time when I was given these subjects to study, me and my friends would talk, okay, this is crazy. I want to design electronic circuits for optical communications. A modeling and simulation is not really making that much sense for me. Or maybe introduction to algorithm, that wasn't making sense to me. Why do I learn introduction to algorithms? The guys from DSP, digital signal processing, and the system theory guys, maybe they need, but why do I need? But as and when I went forward with my career, I really understood, okay, what this means. I definitely have to know the algorithms involved in a design. System theory is more general. Everyone has to know what a linear system is. So I would still understand. Modeling and simulation, you have to, when you are designing an autonomous parking system, you can't just design, you first have to model and simulate it. And as we move forward in time, we have to design really critical systems, zero errors possible. How do you make sure, unless and until you are not modeling and simulating it, and then making sure that, okay, what you have in mind is doable, and then you go for designing. Design itself is extremely costly and intense task, and no one can afford to directly jump to a design process unless and until he has some idea that what he is thinking of designing is actually capable of working in a restricted environment. In restricted environment means that your resources are restricted, the technology available has a limit, and then you are saying that I have to design this, is it really possible to do? So that brings modeling and simulation. Now that's part of my day-to-day job. And this is, I would say, my bachelor and master's program, which has a span over 12 years. Yeah. What it really means, if you are a student today, and I mean a bachelor student, not even a master student, we are not going there. You are trying to start your engineering career and you want to pursue a btech degree. I took this from IcfaiTech. So our college's website. I was really curious to see that what has changed in this electrical engineering field, or the study of electrical engineering, and what is being taught by university. it has been some time since I last saw this. So I thought, yeah, let's have a look what is going on. And this is amazing. I mean, just look at this. The list, it says the list of electives for btech ECE. This is crazy. The list of the list here is huge. And the span of the list, we have optical fiber communication, we have radar, we have CMOS analog integrated circuit, we have embedded systems, there's image processing, there is digital control systems, there's power electronics. This is amazing. I mean, in a bachelor's degree where you are going to get a BTech, you really are combining tons of different fields together and giving a student an option that, okay, you decide what you want to choose, you decide what you want to do, and then choose based on that. This option was also available to us, but because the new age engineering mindset was not there, to us, it was really, the focus was really to the core subjects. But because that does not work or is not going to work in future for a engineering student, they have to offer these many things. And if you think that this could be made cost effective for a university, I cannot imagine how that business runs today. I mean, how would an engineering college bring all these faculties together and offer these many subjects and still be cost effective? Yeah, it's also a business. They have to earn, they have to eat as well, the professors and tons of administrative staffs of a college. But still this is happening. And the major reason is that automobile company, that audio, Mercedes there wants these kind of engineers. They are the businessmen. They have that vision to look into future, and they know that an electrical engineer like me, who only had core engineering knowledge in CMOS and digital analog circuit design, would not be enough for the future. So they say that we need interdisciplinary students. So the colleges, they have to define their curriculum in such a way that they can offer these things to the student who then chooses and then goes into the market. If you go into the market and then if you do not have the required skills, then it really makes it difficult. Having said that, does it really mean that if I had to go today to market with my skills, considering only bachelor's, I'm not talking about master's, let's say that bachelor study which I did in 2004, 12 years ago, I was doing that today, and then I was thinking that I will get a job in market. Does this means that my this thinking is wrong? Absolutely not. Absolutely not. And why I say that? Because just the term new age is fancy. Engineering is still there and no one can change it. You definitely need core engineering to build everything else. Remember the mechatronics drawing. We had electrical engineers there. The electrical engineering was there. It means the electrical engineers are there. So the importance of core engineering is still there. But this new age thing, the doors which it opens are really vast. So as an electrical engineer or as an electronics engineer, I get to work for electronics devices which are used in optical communications. But for me, with this electronics engineering basics, I can also design electronic components for a laptop, for a TV, for a mobile, so electronic industry itself. I can also design an electronic component for a car. So I have a job there as well. Yeah. So you see the basic engineering knowledge which I have, that is opening few doors for me. And if I add it with this interdisciplinary engineering field knowledge, I am really opening even bigger fields for me. Yeah. So In my perspective, in my point of view, this is what it means for the new student. This is what this fancy term new age means for the new for the students who are coming. Now, so many subjects, so many careers. The simplest question to ask is, how do I choose? Yeah, I mean, to me, I always knew that, okay, electrical and electronics engineering, this is what I wanted to do. I joined here in IcfAI. There were subjects first 2 years where you were offered the subjects from all disciplines, where you get to learn a bit or two about every field, and then you really see, okay, whether you fits in or not. So electrical and electronics engineering, I saw myself that, okay, electronics engineering is what is I want to do, and and I went ahead with it. But now that option is even vast. In fact, it's huge, and you have to really choose. How do you decide how to choose? And a student from India, especially, I would say, has different options than other countries. So I will give you an example what I have seen here in Germany. After your schooling, after you have completed your 12 or 14 years of school, student takes 1 year of gap, for example, and then goes and looks for a small paid or unpaid 2 hours a day or 4 hours a day internship in the field where he wants to work. So to give an example, I have seen just out of school teenagers assisting doctors in their clinics with some very basic functions, like maybe maintaining a record or taking down a note or something like that. Very basic functions. They go there and they ask for internship. Doctor, of course, needs somebody to help with him, and then he offers him this job. And when I had an opportunity to speak to one of this teenager, I said, okay, why are you doing this? He said, I wanted to pursue a career in medical, but I do not know I would be able to do it 8 hours a day, 5 days a week, and for 35 years. Absolutely valid question. In your mind, you want to become an engineer. Can you really do it? Once you are an engineer, would you really like it? If you are not, then you are stuck for 35 years. So you have to really think from this perspective, that what you want to do. And once you have decided, then the question comes that how do you choose it? So the very first thing is your career selection. And the matter of fact that you are on this call, it makes clear that you already have decided engineering as your career, whatever may be the reason. And I really appreciate your decision. Once you have decided your career, then in engineering, you have to really think of a field selection. Oh, by the way, the process which I am mentioning here, this is my absolutely personal point of view. There's no right or wrong answer for this question. There are tons of right answers for this. I'm just showing you one here. So once you have selected your career, then you go to field selection. And the obvious question today is that which engineering field? And the way I see it, there are two ways to answer this. First one is you do a market study, you look into future predictions, and then you come to know that, okay, this is what is going to happen. Yeah, for example, you talk to ex-students, or you talk to faculties, your family members, or whoever, or internet, you look on internet and see what's going to happen, and then based on that you decide. And the other option here is that your own personal interest. I mean, if you want to become an engineer, you would have known this since some time, and you would have some idea already in your mind that what do you want to do as an engineer. You want to design a car, you want to design an optical communication system, electrical engineer, and blah blah. You really know that you have some idea in mind. Now with this, it could also be mechatronics, or it could also be a core engineering field like mechanical or electrical. Although when you are doing a market study and future prediction, and when you do a Google search for engineering, your first page would be full of new age engineering. Yeah, you will see all the fancy terms again: autonomous driving, 5G, and blockchain, and big data, and all. Yeah, but I would personally say that it should be your personal interest. I mean, big data definitely has a future. but so does mechanical and electrical engineering. So why should you go to big data just because internet is saying that this is what should happen, and you should avoid your personal interest, which is probably in electrical engineering? And this is why I say there's no right and wrong answer for this. I would suggest that you go with your personal interest and then see where it fits. And then the third term comes the university selection, which I would say is not that difficult today in today's environment. The university selection. How do you choose a university? There are tons of the list really goes on. It's tons of option here. Some of which I say structure of the course, what is being offered in engineering field of my choice, electives, and what options do I have in terms of internships. Yeah. So when I was studying when I was in bachelor's, IcfAI University, we had 2 internships there, internship 1 and internship 2. And what really happens in engineering is that where possibility of error is 0, you really need somebody who knows his thing. Yeah. So an engineering job, whoever is offering it, would like to see a person who has some practical knowledge. But as a student, how will you get practical knowledge? These are 2 absolutely contradictory things. Yeah. As an engineer, I want to hire only people who has some practical experience, so that I could avoid this mistake of hitting a child in parking house. But then as a student, how do I bring my how do I get practical experience? And this is where the internship concepts come in. So in my times, there were 2 internships, 6 months, and one was 6 months, the biggest internship. Really helpful, because that's how I got into the core analog and electronics, analog and mixed signal designing. In my internship itself, I had an opportunity to design some of really huge circuits in analog designing, yeah, voltage controlled oscillators and some operational amplifiers and so. So the internships, what makes is really important. And second thing, what I have learned now, when I was approached to be part of this webinar engineering, I asked, okay, so what is going on in the university now? And I came to know about this TIP program, technical internship program, something like that. So the naming is not important. What really is that the university is making a small group of some 4 to 5, 6 students, and then they are going to the company, to an engineering company, and saying that, okay, here are 4 to 5 engineering students. We are also offering you place in our university where you can come and talk to. And what we are requesting you, that you please give these students a small engineering project. Yeah. And then outcome of that engineering project, you try to use it somewhere in your company, yeah, somewhere in your line of product, or yeah, somehow in your company. So oh, I'm really sorry, something is going on the next floor. Am I audible? Still audible? Is it clear?
Yes.
Yeah, yes, please.
Okay. There's some disturbance outside, I think some construction work. Anyway, so with 2 internship programs, you already get 8 months of practical experience. But then this is again an initiative which is on that direction, which says that a student who is coming out of his student life has some practical exposure. Yeah. And this is really important. And this is why I say that when you're choosing a university, you have to really look what options university is offering. Yeah. What are you really getting? Just the knowledge from the book? Maybe some practical experience, maybe vast practical experience. You have to really look into it. And then, yeah, another important point is the faculty members. You really have to look that who are your faculties, how long they are there, and what they have done. So to me, it's really good to see that all my professors whom I interacted in my bachelor's, they are still there. I mean, the head of departments, Professor Kishore Kumar, Professor Nair, Professor Renu Rani, they are all still there, heading their departments as they did in 2004. And as I said, the list here goes on and on. Yeah, of course, you have to look into tens of different things based on your resources available. But really, from engineering points of view, at least these 3 points you should definitely consider. So once you are into university, what does your career path look today? Yeah, for me it was different, but what I see today is different. This mechatronics and this new age things are being really technology. They are making technology change faster. So what really do you think will be your career once you have gone through the engineering studies? So I took example here of an electronics engineer for wireless communications. Yeah, so I could relate to this field directly, and this is what I take. So if you start in 2020, you have 4 years of btech degree planned. So 2024 anyway. Now after that, you have 2 options: either you go for job or you go for higher studies. Yeah. So if you go for job, and when you are out in the market, what you will see is that there's 5G infrastructure deployment all across the world. Yeah, I'm not only saying that Europe or India or America, all across the world. So this has already started, the 5G infrastructure deployment. You would still say this is going, because this is not really an easy task. And yeah, depending on companies, depending on a country's resources, this could take 2 years or 5 years. And then in next 4 years, what will happen is that the next generation 5G equipments will be developed. So what I mean is that this next generation equipment is that we all know Intel is famous for bringing 4th generation processor, 5th generation processor, 7th generation, 9th generation, and so on and so forth. So what they do is that the underlying technology, 7 nanometer, for example, is same, but they improve it, they refine its manufacturing process, they refine its engineering process, and so the product becomes really better than the previous one, and they call it next generation. Yeah. So what you will see is that what is being deployed now would be, let's say, the 1st generation 5G infrastructure, and what is going to come in 4 or 5 years would be the next generation, 2nd and 3rd generation 5G equipments. Yeah. And by this time, let's say 4 to 5 years, the 5G would be in place. People will already be using it. And then there will be time of the cross-domain use of the 5G, and which will be, for example, in autonomous driving. Yeah. So using 5G technology, a car here would talk to another car on the same road, maybe 100 meters behind, and they could talk to each other and maybe avoid collision. Yeah. So this is what is definitely coming because of the 5G. So these will be some of your options where you will see yourself if you start looking into jobs 4 to 5 years from now, and especially in electronics engineering and wireless communication. But what happens if you are planning to go for higher studies, your masters and PhDs? So after 2024, you need at least another 2 years. This is the minimum. I would say maybe 3 years, depending on your preparation time and application and everything. So 2026-27 time is when you will be finishing your master's study. Maybe you decide to go for a PhD then. And if you decide to go for a PhD, then there will be huge chances that you will be working in 5G wireless networks. And I'm really not joking, as in 6G networks. I'm really not joking with this term 6G. Yeah. You are hearing 5G in some time, and 5G is now being deployed. But what researchers are doing, that they are already planning 6G, and this is what new age engineering is. 5G is being deployed, it's ready. So what do engineers and researchers do? They have to move forward. So they have already started thinking 6G. The IEEE website, yeah, our bread and butter for engineers in terms of publications and papers and knowledge. They have this crazy title. If you look here, 5G is old stuff. Let's focus on something exciting, 6G. And I'm not sure if you could see the date. The date here is 19th November 2019. Absolutely crazy. He says in last year, November, he says 5G is old stuff. Let's think about something exciting, which is 6G. Yeah, so I'm not joking when I'm saying that after your master's, you might have opportunity to get a PhD in 6G wireless. Look at the timeline here for 6G. This third row here. Yeah, by from the middle of 2025, the specification definition phase for a 6G wireless network begins. And this is the time frame you are also looking to start your PhD or maybe your career after a master's study. So if you're going for master's, you're going for PhD, you're interested in research, this is where one of the field, this is where you would get into in wireless communication. For sure, this is going to happen. In last 10 years, this is what has happened with 5G, and next 10 years, this is what is going to happen with 6G. So this is one of the examples. There are tons of other examples. Now, the example which I gave, it has again underlined, let's say, assumption that the environment, the ecosystem in which we are living remains same, which is not really the case. We already know with Corona today. Yeah, so you have to do some research, and I did some for you here with from India's point of view, and look at that. And again, I am focusing on electronics designer for wireless communication. Yeah, and I've only focused on that, and I look into what is actually happening in market. What does business and governments doing? Let's just look at this. The FDI announcement for this year, 2020, Geo platform 1.04 trillion rupees, and it says largest continuous fundraise by any company in the world. This is in India happening with wireless. 1.04 trillion. So what is Geo going to do with 1.04 trillion rupees? Yeah, the idea is that they are going to deploy 5G infrastructure and then build the whole ecosystem around their wireless network, and then get benefited from e-commerce and online videos and movies and tons of sharing possibilities and apps and blah and blah. Yeah. So when a company is investing this much, is ready to invest this much, it definitely means that something is there for engineers there. Because without engineers, who would do this job? Yeah. Without engineers, what would Geo do with this 5G deployment? Look at Amazon India's investment, $1 billion, huge, absolutely huge. And this is for digitizing small and medium businesses. No digitization can work without a strong wireless network. Without a strong wireless infrastructure, it cannot work, impossible. Look about what MasterCard is saying. Yeah, of course, Geo is bringing wireless infrastructure. Amazon India is digitizing business. Someone has to take care of the payments. And this is not to forget about our own Paytm and PayPal and tons of different things. And MasterCard has brought in already $1 billion. And this is all what we're talking till June of 2020. Yeah, still half a year to go, and we already have this investment. So where is this investment going to go? Yeah, 5G deployment, wireless networks, the backbone optical communications network, your mobile phones, and these things. And when this much money is coming into the market in one particular field, it's very clear that an electronics engineer in wireless communication has a bright future here. And not to forget then our current situation, unfortunately, the virus situation, climate change, US-China trade war, and so on and so forth. This list is also never ending. But what all of these have in common, that they all indicate that engineers and engineering processes, they must evolve, and they have to do this rather quickly. Yeah. So what it means is that the companies are looking for decentralizing their operations and expanding it as much as possible, because they are not really sure that if something goes wrong in one place, what would happen to their business. So the real-time effect of coronavirus in companies is this decentralization. Things, for example, manufacturing things coming out of China, that is being decentralized. The companies have started looking into processes where, okay, the whole research and development is not happening in California. it has to happen somewhere else as well. Because if California is shut down, if the Silicon Valley is shut down, then it does not mean that the company has to lose its business. So they really have to decentralize processes. And all these things, what we talk about this new age engineering, what is happening in market and the career path and everything, all these things really means one thing, that engineering is changing, and so does your profession as an engineer. This is what I all had to say about this new age engineering. I am open for questions, and its slide says questions, but it's really open forum. So your suggestions, you want to bring any points to table, then I'm open for discussion, and I would really appreciate. Is there something specific you want to know? Please ask. Okay, I guess no question. Is somebody speaking with mute? Then maybe.
Yeah.
Okay.
Good afternoon, Ajit. I am Dr. K. Vivekananda, Department of Mechanical Engineering. Yeah. So coming to the new age technology, it was a good talk actually. Really useful actually. As a assistant professors, we will enhance our knowledge to the new age technologies. It is useful to everyone, not only for the student but also for the faculty community. Now my question is, how can you justify, for example, there are core branches already you coded in between, for example, mechanical, electrical. How can you justify for the new generations to take that core branches instead of this AI or these? I feel especially these are additives to the core branches. These new eras, whatever the you spoke about the sensors, advancements, but you cannot change the core. I think so. In the automobile, if you take, you cannot change the Carnot cycle or diesel cycle or auto cycle, but you can add latest technologies into that automobile engineering. So how can you justify that new students can take these core branches instead of that advanced or new era courses like mechatronics, as you said, or data science or blockchain, something?
Yeah. First of all, I really thank you. Yeah, this is really amazing question. Yeah, and for most part, what you said, I absolutely agree with you. Yeah, engineering as core is based to everything which exists in technology and everything which is to come in future. And I absolutely agree that the core of engineering cannot change. Yeah, but as I suggested, but as I pointed in that mechatronics slide, yeah, that the software engineering remains same. The software engineering is core, but then the underlying technology for the software engineering is changing. So I will give you my example. When I was studying electrical engineering in IcfaiTech in bachelor, what I learned about were devices, resistors, integrated resistors, capacitors, inductors, and definitely CMOS, complementary metal oxide semiconductor transistors, the CMOS transistors. And the structure of CMOS transistor was what was being taught to me, that this is a 4-terminal device. This is where N region, this is where P region, and this is what is being used today to design electronic circuits. And all our study were based around these active and passive components. And this was our core. This was our core of electronics engineering. Once I have understood the device physics of the underlying electronic devices, I could build my career on that. But what is happening today is this most important 4-terminal transistor, which has a structure, this itself has changed. Yeah, we are now in an era where most of the transistors are FinFET transistors. So now what is happening is that I am designing the same voltage controlled oscillator which I was designing earlier with the CMOS technology, but now I am doing that with FinFET technology. So the phone, a mobile phone from Nokia 10 years ago was using electronic components which were designed by an engineer like me, but using CMOS technology. And today when I design the same phone for Apple and Samsung, I do that with FinFET technology. Does this mean that the design process, the knowledge of voltage controlled oscillator is different? No, that's the basic. Yeah, that's the basic. The voltage controlled oscillator still remains same, but the technology which I use to design this has changed. So this is what it means with the core engineering. If mechatronics is involving electrical and mechanical engineering, and if it is bringing them together, then as I said, they are forming mechatronics. But somebody in the background has to really update mechanical engineering itself. Someone in the background has to really update electrical engineering itself, so that mechatronics as a subject could get benefited from new technologies. So, and this is why I say I absolutely agree. It is, no one can underestimate the importance of the core engineering: mechanical, electrical, electronics, chemical, civil, automobile, whatever has existed since years. It's impossible to change. The law of physics remains same, and the engineering remains same. But the outcome of engineering, which is the technology, this has to definitely grow. And this is not possible, let's say, in a standalone fashion where mechatronics definitely justifiable. Is that what opens which and how many doors for you in your career path? I mean, to me, if you say blockchain and big data, yeah, I do not want to do that. Rather give me a core mechanical engineering, and I will be. And believe me, all engineers with whom I work today, they say, I do not watch me FinFET transistor. It's really, really boring. Please give me back that 10 years ago 130 nanometer transistors and CMOS transistor. That is what I want to do. But the thing is, as a consumer, I demand that my mobile internet speed is 1 GB per second. Is 130 nanometer capable of doing it? No, it has to be done on 7 nanometer technology. And so as an engineer, I have to do this. But where does my interest lies? Core engineering. I have seen my father working as mechanical engineer all his career. And for me, core engineering is everything. But it's really about individual's choice and your analysis that what doors it opens for you.
Yeah.
From technical point of view, yeah, it's undeniable that core engineering is the base of the engineering, and everything has to be built on top of that.
Yeah. Thank you, Ajit.
I hope this answers your question, sir.
Yeah. It's absolutely, perfect. Then I also convinced a few of the points with you, and agreed also. So can I add one more question for you? Yeah.
Yeah, sure, sir. Please go ahead.
So, as you said, new era engineers, new era engineering, what is the scope of that engineers, especially in India? Because I heard many reputed institutes started this mechatronics and other, advanced engineering courses, but they failed because there is no much government, because every engineer is looking for the government jobs after the completion of their btech. So there is no much scope to enter this new era engineers in India, it seems. So what is your opinion on that?
I would once again bring you here, sir. So one thing we know for sure, that engineering is going to come out of China. No doubt, this is going to come out of China. Apple has already started doing this in terms of their chip designing. Yeah, and more or less, this is also sure for US, because in last presidential election, what happened and what has happened in last 5 years in terms of their policies and all, we all know. what their president has done. And now the fear really is in US is that if the same president comes again, it is going to be really catastrophic for the companies. And even if the other president comes in there, with the current socio-political environment, it is not really sure that how would California survive. And the company who is investing billions of euros, billions of dollars, it is really not making sense for them to keep all their R&D and all their engineering at one place. No, it's not possible. They have to bring it out. This is one thing from private companies' perspective, and then comes the government. Yeah. So what I'm saying is that Apple is going to bring its engineering to India. Good. We have a job opportunity with Apple. Now, what it means for government jobs? Do we have really there? So look at this FDI announcement. This FDI announcement itself suggests that there is something in mind of government. Yeah. If Make in India initiative of Indian government picks up, yeah, if this really kicks on, and Apple is forced to bring its business here, so does government for their government projects. There are projects in government which cannot be outsourced to outside companies. This is a basic, let's say, a business and economic law from any country. You can't source your defense contract to somebody who is not Indian, because we don't know what he will do with that. And all of these initiatives, this FDI announcement, I mean, look at this. You're making India initiative, and what outside countries, what outside companies think about India, they all suggest that the new age engineering and its career are definitely on the horizon for Indian students. I mean, this is what my personal feeling is. I look into investment, I look into market news, and then I say what policies government is creating. Is it really going to help the government itself and the outside players? And what I see is that things are going to be decentralized, and there has to be opportunities in India.
Yeah, thank you, sir. Thank you. It was, really a great presentation, and I thank for the, answering my questions also. Thank you.
Thank you so much, sir. Thanks for your question.
Ajit,
Yes, sir.
this is Dr. Brahma.
Sir,
So you gave a very nice talk, inspirational talk on the advancement of engineering. Just I'm curious to know, because you are living in a developed country, in the developed part of the world, the first world country. I'm curious to know that how the development in the science, core science and material science field is contributing or getting integrated to the new age engineering.
the development of
Scientific domain, scientific field and the material science.
yeah.
Simultaneously, the engineering is getting developed and the science also is core science is also getting developed. So how are they integrating, reciprocating with each other?
Yes, so I would like to bring your attention to this IEEE picture, sir.
Please.
Anything which is happening in the scientific community, yeah, whatever research or everything is happening. So what I mean, I said 5G is just beginning to deploy. Yeah, and 5G is already a cutting edge new era engineering. This is already a cutting edge new era technology, and this is starting to being deployed. But does that means that the scientific community sit and wait for this to be deployed and see how it happens and then go for and then start thinking about the next development? No. The new age engineering for me today is this 5G. But for this new student who is coming in, who has 4 to 6 years of study life in front of him, for him the new age engineering would be this 6G, which is already being, for which the talks have already been started. So the scientific community in the background, all these big engineering think heads from Cisco and Juniper and Nokia, and they all have started sitting together, and they have started talking. Okay, 10 years ago we did this for 5G specifications. We defined, we made a process standardized, and then we gave it to further engineers and universities for do the research on this. But now it's time that we start doing the same thing for 6G. So the scientific community, what they are doing in the background, this is in fact one step ahead of new age engineering.
Yes.
I call new age engineering 5G infrastructure, but this community, which is sitting in some IEEE location, I don't know where, this community thinks 6G for them is the new age engineering.
Okay.
And this is true integration of the scientific development in new era.
Yes. Great.
Somebody has to do this specification definition. Somebody has to set the path that how is world going to look like in 10 years.
Yes.
And the guy who is doing this, for him, the technology from 10 years is important, and he is calling that as new age engineering with comparison to what I'm calling a new age engineering. So I already have completed my studies. For me, 5G is more than enough. Yeah, I'm designing 7 nanometer devices with 5G, and I'm already fed up. Okay, this is already difficult to design. But the engineer who is coming, who is going to study and come out of engineering in 4 years, he has to really think 5 nanometer design, 10 gigabits speed, and I don't know what else.
Yeah.
And for him, he has to really think that 6G for him is also this new age engineering. And this is how I would say that the scientific community, what they are doing, is being integrated into new era. I hope this is
Yes. I'm absolutely
some clarity.
Yeah, I'm convinced. Thank you.
Yeah.
Thank you, Ajit.
Thank you,
Thanks a lot
Ajit.
for the
Thank you for
questions.
your valuable time. You said that you have meeting in government organization there. So thank
Oh,
you
it's
for
already
sparing
9,
your
yeah.
time.
Yeah.
Thank you for your valuable time and good presentation we had today. So, yeah.
Thank you to the organization, sir. I mean, when I was approached, I was really curious, and I'm really happy today. Yeah, and I would really thank all the listeners and audiences today. Yeah? I really thank you for your time. You have been really patient with all my talk, and yeah, stay safe and stay healthy.
Thank you. Thank you. Have a pleasant
Thank you,
day.
sir.